There's a lot of talk about how antibody testing can help us get back to work before a coronavirus vaccine. Antibodies are your body's defense force. An antibody is also known as an immunoglobulin. It's a Y-shaped protein. Let's say a pathogen, like coronavirus, invades your body. On the outside of the pathogen, there's a molecule called an antigen. You can think of the antigen like an opposing army's uniform. Your body identifies the antigen and then creates antibodies specifically made to bind to that antigen. So why have you been hearing so much about antibody testing recently? There are three main reasons. Immunity. Next to a vaccine, the ideal solution would be for as many people as possible to be immune to coronavirus. Immunity means that you've had the virus already, you're protected from it in the future, and you can't spread it to others. Some have said that antibody testing could even give you a so-called immunity passport to return to work. But it's not that simple. Not all antibodies are created equal. To become immune, your body needs to produce a specific type of antibody called neutralizing antibodies, which binds to the virus and prevent it from attacking your cells. The problem is with COVID-19, we don't know yet what types of antibodies we produced or how long they last. And in order to get those answers, we'll need to study patients who've had the disease for weeks or even months. Understanding the spread. Antibody testing can help us know who's had the disease, not just who has it now. It can help us find people who didn't have symptoms and didn't even know they had the virus. Antibody testing in Northern California has shown us that the disease was 85 times more prevalent than we thought. Knowing exactly how far COVID has spread can help us figure out exactly how many people have gotten it, which help us model better curves and decide when life can go back to normal. Plasma donations. If you've recovered from coronavirus, it's possible that some of the antibodies in your blood could be donated to others to help cure them. Antibodies live within the plasma in your blood. That's a liquid part. Some hospitals have started doing plasma transfusions, but those treatments are still highly experimental. In order to donate your blood, you need to have had a positive test for COVID and to have been symptom-free for at least 2 weeks. Families of critically ill patients have been reaching out on social media for potential donors. But with plasma donations and other treatment like it, we don't quite know yet if it's the way to go. We now know how antibodies work, but how do you know who has them? Testing. There are two main types of tests, lab tests and rapid tests. The advantage to the rapid test is that it's faster, but usually lab tests are more accurate. The main type of lab test for COVID is an ELISA assay. A scientist will take a plastic dish filled with coronavirus, then add a sample of someone's blood. If that blood has COVID antibodies, then the plate will change color and you'll know it was there. There are at least two types of antibodies that the COVID antibody test looks for: immunoglobulin M, or IgM, and immunoglobulin G, or IgG. IgM will appear very fast in your blood after the infection, but it's a big and clunky molecule that's not as effective as IgG and also doesn't last as long. IgG, however, will take a little bit longer to be produced by your immune system, but it keeps you immune for a very long time, assuming that the virus doesn't mutate. The problem is it's really difficult to create tests that are accurate and rapid at the same time. The key takeaway from this is that antibody testing does have a huge promise if it turns out that our bodies create lasting immunity. In the meantime, it can help us understand the spread of the disease better and inform our governments when they try to figure out when life can return to normal. As labs across the world produce these tests, we'll learn more about the extent of the virus's spread and hopefully how we can use our body's natural immunity to fight it until we find a vaccine.